Hello guys. So in this video, I'm going to be doing polarization, intensity, as well as Malus Law. So it's a video I'm going to be trying to explain this new edition of our syllabus. So I hope you watch it until the end. We'll explain some of the graphs that can also be drawn using the law itself. And I'm going to explain also intensity and how you can answer some questions surrounding intensity. This is part one of my three-part series surrounding polarization, intensity, and Malus Law. In this video, I'm going to be explaining the concept, and in the next two videos, I'm going to be explaining a little bit more, but using questions so that you can be able to understand how the topic actually works and how you can be able to answer questions. So if you like the content, please like, comment, share, and subscribe, and help the video reach other people. Okay, so let's begin. The first thing that our syllabus requires us to know is that we must recall that intensity is power per unit area and that intensity is related to the amplitude squared. The first thing that we'd want us to discuss is surrounding intensity itself. So as the syllabus defines intensity, it defines intensity as the power, okay? So intensity is the power per unit area. So basically, if you have a certain area, you're going to emit a certain kind of energy on that area, okay? So intensity generally measures how that area, for example, if that area is, let's say, constant at 2 square meters, something like that, and you have a certain light that you're shining on that area itself, if the power of the light increases, let's say it's 25 watts, for example, right? We say that that light is very intense, right? If it decreases or if it increases, maybe let's say to 100, right? If it goes to 100 watts, we say that the intensity has actually increased because the power per unit area has actually increased, right? As you use intensity in your normal day-to-day life, you usually say that something is very intense if it's done with so much energy, if it's done with a lot of work. But in physics, we define intensity as the power per unit area. Another important equation that they say that you should know is that intensity, okay? So intensity is basically directly proportional to the amplitude squared, okay? Now, this is a mathematical law that has been proven that intensity is related to the amplitude itself, right? So the square of the amplitude is actually related to the intensity. But where does that come from? Well, we know that energy is related to the amplitude. What do I mean by this? Generally, the role of a wave is to transfer energy. Let's say from this point is generally to transfer energy. A disturbance transfers energy from one point to another. So this is, let's say this is the amplitude, right? This amplitude A. But if it becomes more intense, it means that the amplitude actually increases. So the amplitude will be a little bit much higher, like that. Meaning that comparing wave A and wave B, so this is wave A and this is wave B, comparing these two waves, one of these waves has a higher intensity, simply because it has a higher amplitude, right? So this amplitude means that this wave can actually transfer a greater amount of energy, meaning that a greater amount of energy, okay? So a greater amount of energy is actually because it has a higher amplitude. So the higher the amplitude means that that thing can be able to transfer a high amount of energy. But remember, I've said that intensity is actually the power per unit area. But power is generally the energy that has been transferred per unit time, meaning that intensity and energy are related. So if amplitude affects energy and power is related to energy and intensity is related to power, generally means that intensity is related to the amplitude. But what's very important to understand is that you should know that relationship and you should be able to use it as well, right? So how do you answer questions that come with intensity? Cambridge usually asks questions around intensity. They give you a scenario before. They can tell you that the intensity has changed, so find the new amplitude. Then give you a scenario where they say that the intensity is like this, find the amplitude, or they can give you an amplitude, and then they say, find the new intensity. So we're going to be looking at questions like that, okay? So basically, the law is pretty simple. I've said that intensity is directly proportional to amplitude squared. Now, what does this mean? Well, if you look at variation itself, whenever you say something's directly proportional, you have to introduce a constant, right? So we say that intensity is equivalent to K amplitude squared. So there is a trick that most people use, but I don't highly encourage it because it can get tricky. So people often use these ratios themselves. For example, if I double the amplitude, it means that since intensity is directly proportional to amplitude squared, if I double the amplitude, it means that the intensity increases fourfold. So it becomes 4i. But here's this an easier way. So the easiest way to think about this is to use the equations themselves, right? So this saves you a lot of time. Whenever you see a question that gives you an intensity before, and they tell you that this is the amplitude, or they give you another amplitude and they ask you to find the intensity, I would advise you use this method. So what do? Let's assume that I'm given an amplitude A, okay? For example, I'm given amplitude A, and I'm told that the amplitude is doubled, right? So it's doubled to 2A. And they ask me, what is the change in the intensity? How do I tackle a question like this? Well, the best way that you can think about this is to use your equation. So we say that I is equals to KA squared. So you say this is the first baseline scenario, okay? The second scenario is you have doubled the amplitude. So it becomes I1 is equivalent to K2A squared, right? So that gives you I1, which is equivalent to K4A squared, okay? So basically this is how you do this, right? But you know that this is the same as I1 is equals to KA squared 4, but this is basically that, so I1 becomes 4i. So this is a way that makes it so much easier that you don't even have to remember the ratios, and you don't even have to look at it all, right? Let's look at another example. Let us assume that the amplitude was once A, and now it's half of A, okay? So we just say again, I is equals to KA squared. Now it's I is equivalent to K half of A squared, okay? So always put that half of A squared, meaning that your I1, right, the next I1 will be K 1/4 A squared, but I1 is equivalent to KA squared 1/4, but all of this is the same as that. Therefore, I1 is equals to 1/4 of I. So basically, this is one method that you can use. You just know that what is your new amplitude? You substitute it into that equation and you get your value, right? So it's a relationship that you can use to find the intensity given a change in amplitude. And the opposite is also true. Since intensity is equals to Ka squared, I can change the intensity and I ask you, what is the amplitude? For example, I can say that I once had I, now I have 2i. Tell me what happens to the amplitude. Again, you still use the same method. You say, previously it was I is equivalent to Ka squared, okay? Now it's 2i, so it becomes 2i is equivalent to Ka1 squared. You want to find what this value actually is, okay? But your value of K is actually A squared I, okay? So it becomes 2i, right, is equals to your value of K here, right, is I over A squared, right, multiplied by that A1, all of that squared, right? So if you go here, right, it becomes 2i A squared, okay, is equivalent to I A1 squared, right? That cancels out. We're left with A1, okay, squared is equivalent to 2a squared. So A1 is the square root of 2a squared. So A1 is actually root 2 of A. So basically, this is a method that you can use to find this relationship. So I highly encourage that you use these ratios because they make life so much easier. Instead of trying to figure out, okay, since A is the square root of that, if I double that, what's happening? You can just use these ratios and they can give you the answer straightforward. Okay, so this is about intensity. So you just need to know the formula about the formula of intensity and how you can make calculations about it. The next aspect that I want you to know is what we call polarization. So our syllabus requires us to recall, to understand that polarization is a phenomenon associated with stationary waves. Okay, so first need to understand what is polarization, why only stationary waves, why not longitudinal waves or other types of waves. Okay, so polarization, as you can see on the screen, polarization is defined as the restriction of vibration of a wave to one direction, that is one direction only, normal to the wave propagation. Now, what do I mean by all of these words? Well, let us go back to the fundamental principle. Light or all transverse waves generally have their vibrations in a perpendicular direction, right? So generally, all their vibrations are in a perpendicular direction. It's something that is known. Okay, so let's say, for example, this direction. Okay, so if we have something like that, this direction is actually perpendicular. Okay, because it forms 90 degrees. It's moving up here and actually forms 90 degrees. But remember, there's more than one way to be perpendicular to a surface. A wave can be perpendicular whilst it's moving in that direction, right? So another wave can be moving in that direction, right? So it's moving in that's still perpendicular, right? So there's more than one way of being perpendicular. And that actually means that waves travel in a variety of directions. This direction is perpendicular to that direction might be perpendicular in another way, that direction might be perpendicular in another way. That gives rise to what we call unpolarized light. Just light that is moving in a bunch of random directions that has no set of direction. So basically, unpolarized light, you see it a lot. It will be represented like that, meaning that it consists of light in a lot of planes. What is a plane? Well, a plane is basically, for example, if you're looking at 2D, that's a plane, right? It's in the plane of the paper itself. But whenever you have wave, it might be in a plane out of the paper. So it might be up or down, left or right, sideways. So there are many planes in which it's moving. It's not only restricted to one plane only. So that's basically unpolarized light. But when we have what we call a polarizer, it causes polarization to occur. It takes all of that light in, so all of that unpolarized light gets filtered out. So this one basically blocks. As you can see, all of that which was horizontal here was blocked. None of the horizontal light was able to pass through, and only light that was vertical was able to only pass through. So basically that's what polarization is. So for you to understand polarization, think of this example, right? Imagine you have a bunch of people that are just moving around in a random direction, right? So just a bunch of people that are standing around haphazardly. And you have to put a door in front of them, but that door only allows one person to enter through. Now, as those people begin to move through that door, they're going to come out of that door in a single file, right? So we have sort of restricted the motions of these people. They were just haphazardly moving around, and we've put a door. We said this door only allows one person to pass through, so it will filter out certain individuals, and only a bunch of people will enter through that are moving in one direction only, not any other direction, only one, right? So that's polarization. You have a lot of waves that are vibrating in a lot of directions. So by putting a polarizer, we're sort of blocking and saying we don't want the other waves. We only want this kind of wave, and that polarizer will help us filter out the light that we don't want. Okay, so very important for you to understand that. So once we have understood what polarization is, it's very important for you to understand that. So polarization, an important thing to note, only happens with transverse waves, right? It doesn't happen with longitudinal waves. Why is that? Well, I want you to think of this. Think of this. In longitudinal waves, the waves vibrate parallel to the direction of propagation, right? So the waves vibrate parallel to the propagation. So basically, this is our longitudinal wave, right? But if it's a transverse wave, the waves vibrate perpendicular to the direction of motion, right? So if it's moving up there, the direction will be parallel, right? So like I've said, there are many directions in which you can be perpendicular to something, right? So we can filter out all those directions that don't really align with a certain plane that we want. But with the longitudinal waves, we don't really have the freedom to do that. Why do I mean by this? Well, if we were to put something that's horizontal here, right, it's going to block out all the wave because all the wave is traveling parallel to the motion, right? If you put something vertical, all the wave is going to pass through. So you can't really block a sound wave because if a sound wave is just made up of compressions, refractions, compressions, refractions, if you put something vertical, it allows all the wave to pass through. But if you put something horizontal, only a few of that waves, in fact, no wave passes through because the wave motion and the direction of vibration are actually parallel. So longitudinal waves can never be polarized. Why? Because their direction is parallel to the direction of propagation. But transverse waves can be polarized because the direction of propagation is perpendicular to the direction of vibration of the particles. Very important for you to understand that. Now that we understand that, we can then move on to Malus' law itself, right? What does Malus Law say, and how does it apply when we are solving our questions? So in 1809, a guy named Etienne Louis Malus came up with this law that was known after his name to be Malus Law. And at the beginning of the 19th century, the only way to generate polarized light was with what we call a calcite crystal, right? So basically, it is a crystal that you can move in different directions and can allow light to pass through. And Malus discovered that light consisted of polarizations, right? As I've said, that these are just variations that travel perpendicular to each other as he viewed the light on his crystal. Then he discovered a law, right? So his law then measured the intensity of light after he passed through a polarizer. So he had unpolarized light, for example, right? Then he put a polarizer. So in this line, he then put a polarizer, right? So after putting that polarizer, he discovered that, okay, if you were to put a second polarizer, right? So this is basically what we call a polarizer. So the second one is what we call an analyzer. So Malus discovered that if he was to rotate this one, right? So it's basically the analyzer itself at a certain particular angle, the intensity of light that it gets out on the other side actually changes. In some instances, the light was completely dark. In some instances, it was a bit brighter. In some instances, it was fully bright, just by rotating the angle of the analyzer. A simple way that you can think about how some things changes because of change in the angles is to think of a water tape, right? You've all opened a water tape at some point, right? In a water tape, you would appreciate that as you open the valve, water starts to flow out, right? Very important. But have you noticed that water just doesn't flow out in a large amount and it just doesn't stop? It varies in between, right? As you open your tape, it starts to flow out with more and more pressure until it flows out with full pressure. Or you can turn off the knob and the water can stop moving. Basically, this principle is because of the valves inside of the water that open up at a certain extent because you're turning the knob. So by turning the knob fully, you open the gates fully and all the water passes through. But by closing the valve, you're sort of closing those valves in different extents so that the water can either be no water in or it can be a lot of water out. So we can assume that, let's assume that this knob can only be turned 90 degrees, right? So if you turn it so if it's locked, right, no water is coming through, let's say that's 90 degrees, right? If you're to open it, right, so let's say it's like that, it's 90 degrees. If you're to open it, it will become vertical. And as it becomes vertical, all of the water will flow throughout, right? So basically, this is how the intensity of the water changes. As you're opening the tap, no water, all the water passes through. As you close the tap, no water passes through, but there can be intermediates in between. This is the same with Malus Law. If you have an analyzer, if you shift that analyzer at certain angles, certain amount of light is going to pass through. But Malus then discovered that the intensity of light that he has after it has passed the analyzer, right, is actually related to the intensity that light has passed through the polarizer itself, right? So if light was to pass through the polarizer here, as it would appear and it's about to enter the analyzer, he discovered that the angle that he would shift, so this angle, right, if it was a certain angle theta, the angle that he would shift his analyzer by actually meant that the intensity that comes out was related to the actual transmitted intensity. That's when he came up with his law. So basically, Malus' law states that the intensity that you get out, the intensity of the transmitted light, is directly proportional to the square of the angle between the polarizer and the analyzer. The famous equation, I is equals to I naught, okay? I naught cos squared of theta. So basically, this is the equation of Malus' law. But here's where it gets tricky, guys. The most important thing that most people find difficulty in is finding this angle theta, right? So that's what I'm going to be talking about in a couple of seconds so that you understand what is this value of theta. And if you have that value of theta, you can work any problem that you'll find on Malus' law. So let's go through it, right? So I need you to understand three important key facts, right? The first thing is the polarizer. The second thing is the analyzer. The third thing is the transmission axis. If you just understand these three things, you can understand Malus' law completely, right? So here's one first fact that you have to know, right? So this is something that you have to know. There are reasons why it happens, but usually your questions will give you light that is coming out of a first filter going into an analyzer. But just in case they give you a certain question, you should know that if you have unpolarized light, as it passes through a first polarizer, if it's unpolarized, its intensity reduces by half. Remember what intensity is, the power per unit area. Intensity for light, okay, so I forgot to mention this, but intensity for light is actually related to the brightness of light itself, right? So very important for you to understand this. So intensity is actually related to the brightness, right? So it's related to the brightness if you're talking of light, right? So if light is very intense, it means it's very bright. For sound is actually the amplitude, the loudness, right? So if you have a high amplitude, you have a higher loud sound, your sound is more intense. Basically, that's what happens. So think about this. If unpolarized light passes through the first polarizer, its intensity reduces by half, right? But you don't have to worry much about that. But I would advise you that you really just know that it exists. They might ask you graphs around that, but you just need to know that if light with I naught enters a polarizer, it's going to come out with half of that intensity. But if we're now looking at light as it's about to enter an analyzer, so as you're about to answer more questions, you see that they'll just tell you that light is vertically polarized. So they just assume that light has already been vertically polarized for you. So it's already moving in one plane. So they just say, we've shifted now the angles of the analyzer. So find the intensity that is transmitted, right? But generally, what you have to understand is what is the angle theta. So like I've said, you have to understand the polarizer, what the analyzer is, and what the transmission axis is. So the polarizer is where light first gets filtered out, okay? So as light now comes and is beginning to enter the analyzer, the angle that we're interested in, get this guys, the angle that we're interested in is the angle between the polarizer and the analyzer. That is the value of theta. It doesn't matter if the polarizer is positioned at a certain weird angle or any other angle at all. The angle that we need is the theta between the polarizer, the transmission axis of the polarizer, and the transmission axis of the analyzer. So let's look at this first one. So its transmission axis is basically like that. Okay? So that is the transmission axis of this light wave as it's about to come, right? So I need you to be thinking about, okay, what does this actually mean about the analyzer itself? So whenever we're now considering the analyzer, we have to look at those two things. Identify what is your transmission axis. An axis is basically like a y-axis and x-axis, right? So it's the axis of transmission itself. So if I go here on my analyzer, so I usually, to make this easier, I go on my analyzer, I take this axis and I place it on the analyzer itself. So this will be the axis that I'm looking for here, right, on my analyzer. And this is my reference point. So basically, this is my reference point for me to start measuring an angle. You know that when you're doing degrees, you need a reference point, right? For example, if I'm about to measure this angle theta, right, this is my reference point. I start putting my protractor here, and I use this as a reference point to go from here up until that, up until there, right? So if I want to find this angle theta, I'll then have to draw this second transmission axis of the analyzer. And theta is actually from the transmission axis of the polarizer to that angle. That is your value of theta. And Malus Law says that that value of theta is related to the intensity that comes out. Malus Law says that the intensity that you get out multiplied by, so this is half I naught, remember it's just half I naught. When you just say it's half I, right? This intensity, I naught, I is related to I naught cos squared of theta, right? So if we know this angle theta, we can find the value of the intensity that comes out. How? Because if we're given the initial intensity, if we just say cos squared theta of this angle, if it's 30 degrees, I get the intensity that comes out. That is how Malus Law works, right? So understand this. Whenever you see a Malus Law question, ask yourself this question. What is my angle theta? Go back to your polarizer, draw your transmission axis, extrapolate it even, right? Take that transmission axis, place it on the analyzer, compare now what direction the analyzer is first facing and measure that angle theta. That is basically how you use Malus Law. So remember that tap analogy that I gave you, right? So now we're going to assume that this angle is actually vertically polarized, right? But what has happened is that, so let us look at this one here. We have shifted it to be 90 degrees, right? So very important. We have shifted this angle to be 90 degrees. So I've given you transmission axis like that. So imagine if your transmission axis was like this, right? Imagine if your transmission axis was like that, such that this is 90 degrees. Remember, if light is coming vertically polarized, it's going to hit that transmission axis. So this angle is 90 degrees. As it hits the transmission axis, it can't enter through because the angle is being blocked completely. So no intensity will come through, right? So if theta is 90, basically from the reference angle, if theta is 90, means that that wave can't enter through. But what if theta was 0? What does it mean actually to say that theta is 0? It means that the transmission axis is actually the transmission axis of the analyzer itself, right? So the angle is 0. All the wave passes through, so you get the maximum light that you can get through. If you remember my water analogy, if the intensity is 90 degrees, if you remember my water analogy, there's a point where the tap opens and all the water comes through. That is the same as having an angle of 0. All the light comes through. If the tap is closed, no water comes out. In a similar way, if the transmission axis of the analyzer is at 90 degrees to that of the polarizer, no wave passes through. That is how Malus Law works. And variations of that, like in a tap, gives you different levels of water, gives you also different levels of light. They give you different intensities of light that you can get out, right? So very important for you to be able to understand that, right? So let's look at one last application of Malus Law before we move on to the graphs and we'll be done. What if the question has changed the angle of the polarizer? So most people are usually find the angle of the polarized light usually like 90 degrees or is mostly vertical, right? So it makes them a little bit much easier. But questions may come where the polarizer, so in this case, this is my polarizer and this is my analyzer, are not exactly 90 degrees. So this isn't a 90 degree. It's already initially at 45 degrees like that, right? So initially it's at 45 degrees, meaning that there's already an angle theta that is on the polarizer itself. And I've been asked to find the intensity that comes out, right? So look at this. This analyzer is actually at 0 degrees, right? Okay. So that means that light that is coming out is actually, maybe let's say it's vertically polarized that is coming out. So we have light that is coming in, but we've been told that this angle theta is actually 0 degrees. So how do we find out how these questions work? Well, you go on again, you position your light beam here. Okay, so this is your value of your angle theta. So your value of angle theta will then be the angle between the polarizer and the direction of rotation of the analyzer itself, right? So this angle theta will then be that comparison to that angle theta. Very important for you to understand that. Okay, moving on to different application of Malus Law. So the different cases that you can see, the polarizer might actually be at a different angle than the analyzer itself. So in this example, this is actually the polarizer, okay? So if this is the polarizer, this is actually the analyzer. And these two are not at the same angle. This is at 90 degrees. It's actually starting at 45 degrees. So if you look at this example, this one was at 90 degrees, so we just put it there and we said that theta is this angle, right? But what if this is not also at 45 degrees? What if the polarizer is facing a certain angle, right? What if it's allowing light to only come in a certain direction? In this case, our light is coming only in this particular direction, right? So our light is only coming in one direction only. So what happens then? Well, think about this. If light now suddenly comes out vertically polarized, so basically if light comes out in a different manner than the manner that it was put in, it basically means that light has been shifted its angle, right? What do I mean by this? Well, if we know that this intensity is actually at 90 degrees, we know that this transmission axis, so if we take the transmission axis of the polarizer, so let's put the transmission axis of the polarizer, right? But we now know that this angle is actually vertical. So this light that is coming out is actually to the horizontal. Something like that, right? It means that your value of theta will actually be this angle theta, which will be, let's say, 45 degrees, right? So since it's actually vertical, okay, it actually means that this angle theta is actually between, so not vertical, it's actually horizontal. It means that your value of theta will be the difference in the angle between that horizontal light as well as the angle that is the polarizer itself. So theta becomes from the polarizer up until to the direction that the transmission beam is actually facing. If this analyzer was at 45 degrees, it means that 45 degrees polarizer is also at 45 degrees, so all of the light passes through. If it begins to shift around, it also means that none of the light will pass through at a certain point in time. So basically, this is how Malus' law can be applied. So first, ask yourself this question: what is the angle theta? Right, that's the first question that you need to know. Angle theta is the angle between the transmission axis of the polarizer and the transmission axis of the analyzer. Go to your polarizer, draw a line of the transmission axis. Once you have that line, you allow your light to pass through. Go to your analyzer, draw another line. Make sure that those two lines are visible, and your angle theta becomes the angle from the transmission axis of the polarizer to the angle of the transmission axis of the analyzer. And that is Malus' law, basically. So you can find the intensity that comes out. They can give you a lot of scenarios, but if you just have an understanding of the concept, you can be able to answer any question, okay? And the last part that we're going to be talking about are concerns graphs, right? So these graphs are very important for you to understand this, right? So like I've said, if the angle theta is 90 degrees, we have no intensity, right? So as theta increases, and theta becomes 180. So if theta was 10, I had the highest maximum amplitude. So it means that, so if we're to look at an actual scenario here, it means that if I had a wave, right, something like that, that was coming in a different scenario. So if I had something like that, and my wave was coming in vertically polarized, right? So this is my wave that is coming in vertically polarized, right? And this is my polarizer, okay? So let's put our polarizer here. And so this is our polarizer, okay? And this is our analyzer, okay? So this is our analyzer. So if this angle theta was 0, what this means is that this is vertical, okay? And this is also vertical, meaning that if light comes in a vertical manner, that light is also going to pass out in a vertical manner. So we have the maximum intensity because all the light passes through, right? Remember, that's what Malus' law says. But if this angle was to change, right? How might it change? Well, this angle might be something else besides 0 degrees, right? So this angle, let's say it's 50 degrees, example, as you can see here. Well, this means that if I draw my transmission axis of my polarizer, my angle on this transmission axis of the analyzer is actually theta, which is actually 50 degrees. It means that the light will pass through, but not as the maximum intensity, just a few of it, maybe 0.4, right? Like I've said in my tap, imagine opening a tap to a certain extent, you only get a few water out. In a similar way, if you rotate the analyzer to a certain extent, you only get a few light out, right? But what if theta was 90 degrees, right? What if theta was 90 degrees? Well, let's look at that. If theta was actually 90 degrees, what this means is that this angle of the analyzer is actually something like that, right? So if that angle was 90 degrees, what it means is that the light will not pass through. Well, because if this angle is actually 90 degrees, as light tries to enter through, it gets blocked, right? This will not allow the light to enter through. Light tries to enter, it gets blocked, so you get no intensity that comes up at all. But you can continue rotating this. You can rotate the analyzer again at 180 degrees. 180 degrees basically means that you're now facing this direction, right? So that's 180 degrees here. Basically, you get the maximum intensity. It's back to its positional again. You get to 270, you have 0, you go back to 360, you have all the wave coming through, you keep on rotating and rotating and rotating, and you keep on getting different intensities. So these are graphs that you might need to know about intensity itself. So basically, that is it. That is what you need to know about Malus' law. So a little recap so that we can summarize basically what we've been saying here. Right? We first started by saying intensity is the power per unit area, right? So this was our first objective. And we then said that intensity is direct proportional to the amplitude. Why was this? Because the amplitude is basically a measure of the amount of energy, right? So if you have a high amplitude, we have a higher energy that is being propagated. And energy and power are related. If power and intensity are related, intensity and amplitude also should be related. But the equation or the mathematics, y is I is equals to amplitude squared, is beyond our syllabus, right? So if you want to know that, you have to read other textbooks. There are a lot of textbooks, but it's not exactly required in a syllabus, right? And we also talked of how I is equivalent to Ka squared. And how this equation, remember, removing the proportionality sign, we put a constant K. And how this equation can be used, so this is our summary, and how this equation can be used to calculate equations, right? So they can give you changes in amplitude. Whenever you see a question that says the amplitude has changed, right? Always ask yourself, what is happening? Is the amplitude the one that is changed, or is the intensity the one that is changed? Go back to this equation. First put the amplitude, then put the intensity, and find what happens, right? We also talked about polarization, right? And said polarization is a restriction of the vibrations of a wave to one direction, right? We gave an example of people entering a door, and so that as they enter through the doorway, they're going to be blocked, right? If we were to put a door that only allows one person to come out, we have restricted everyone else, and they're only moving in one single file. So light is unpolarized, and it can be restricted to move in one direction only. And under polarized, we say that polarization can only happen to transverse waves only. Longitudinal waves, it can't, because they move in the same direction as the propagation itself. If you put something vertical, it stops all of them. If you put something horizontal, it might allow all of them to pass through. If you also put something vertical, if it's moving the vertical direction, all of it passes through. So you can't polarize transverse waves. And the last thing that we talked about then was Malus Law. And I've explained how the famous French engineer and physicist Etienne Malus came up with Malus' law that relates the angles of the rotation of an analyzer and the angle of rotation of the polarizer. And we came up with the law of I is equals to I naught cos squared theta. And I said that you should know three things. You have to know about the polarizer. Ask yourself, what is my polarizer? The second thing that you need to know is what is my analyzer? And the third thing that you know is what is my transmission axis? Right? What is your value of transmission axis? And that gives you your angle theta. So basically, that's a brief summary of what we're covering in this video. So I hope you liked it. Please comment, share, and subscribe. So please watch my other video. As you can look here, this is my video of Malus Law's problems, right? So I was weighting some of the problems on Malus Law, and this is a video for the May-June. Okay, so this is for the May-June 2023 question paper 1-1 for physics, and this is again a paper for the May-June 2023 question paper 1-2 for physics. So I hope you check that out, and please feel free to ask any question that you have in the comment section. If there's anything that was clear or anything that was unclear, please comment so that I can be able to improve, or I can be able to further explain anything that might be unclear. Thank you guys. See you in the next one.